Welcome back to the channel. In this lecture series, we'll be discussing about quantitative ability, Vqar problems like relative speed and train problems, boats and races, boat streams. We'll be discussing about all these topics. So starting off, what is relative speed? Relative speed is nothing but it is speed of an object as observed from another moving or stationary object. So you would have had the scenario where you are in a moving bus and you look at a stationary object that you see that you think is whizzing past, but it is actually stationary. On the other hand, let's say you see another object that is, if maybe if you are stationary and the object is moving, so the velocity between yours and the other one is the relative velocity. So the formula to find out the relative velocity is v relative is equal to v1 plus or minus v2, depending on which direction the velocities are. So the applications are to find for the navigation, collision avoidance, vehicle dynamics, and so on. So the importance is that it is essential for to solve problems involving multiple moving objects. So some of the real world examples are like overtaking vehicles, train problems, air traffic control, to find the relative motion of planets, galaxies, and so on. Then the next stage is the empathy. So understanding the problem context. So the challenge for students is that it is difficult to visualize relative motion between objects. And the learning gap is that the confusion between absolute and relative speed, these two are different concepts, but it can sometimes be mixed up, and they can. It is difficult for difficult. It might be difficult to follow. So some of the common misconceptions are that using relative speed is always the sum of individual speeds. So it is not always the sum of individual speeds. It is based on the direction in which each of the objects are moving with respect to each other. So some student questions are like, why do we need relative speed? When should we add the speeds or when should we subtract the speeds? And the real world relevance is that understanding training problems helps in navigation and collision avoidance. So the key concepts in relative speeds are that so the relative velocity formula is as I said seen earlier, v relative or v alpha beta is equal to v alpha plus v beta. As you can see here in this diagram, you can see that v alpha and v beta are there. So the relative velocity is that it is the sum of these two. So it might be better said as it is the algebraic sum of these two. So if both the directions are in the same, if both the bodies are traveling at the same direction, then V relative is equal to, it is the mod of difference between V1 and V2. Then we have, if they are in opposite directions to each other, then we sum them. Then we have time to cross. Time to cross, the T is equal to L1 plus L2 divided by V relative. L1 is the length of the first part and L2 is the length or trajectory of the second one. The distance covered D is equal to V relative multiplied by T, the time taken to cross. So from this, we can see the key variables are speed V, length L, time T, and distance D. So then comes the ideate part. So we have different types of train problems where first one is same direction where the train moves in the same direction as the with different speeds. So how do you find the V relative? The formula is V relative is equal to V1 minus V2. Put it in mod. So it should always be positive value. Then we have opposite directions. So when the trains are moving in opposite directions on the same track, then V relative is equal to V1 plus V2. So we sum both these velocities. Then we have crossing platforms or bridges, these sort of problems where the train crossing stationary objects like platforms or bridges. So the time taken for the train to cross this is T is equal to L, L of train plus L of object, length of the train plus length of object divided by velocity of train. So relative speed formulas and principles are mentioned here as seen earlier. V relative is equal to modulus of V1 minus V2. If they are in the opposite direction, you sum these two together, and if the it is you are asked to find out the time to cross, then it is T is equal to L1 plus L2 divided by V relative. So that is the time for two objects to pass each other. So the key principles here are, you should first thing you have to check is the units, convert them for consistency, then consider the direction. So we have to find out which direction it is moving, and we have to assign positive or negative sign to them accordingly. Then we have to add the lengths of to complete crossing, and then find the absolute values for speed. So trains moving in same direction. So relative speed formula is V relative is equal to V1 minus V2. So we'll see that we see a problem using that. So train A is moving 200 meter. Train A is 200 meter moves at 60 kilometer per hour, and train B, which is 150 meters, it also moves at 40 kilometer per hour. So these two are traveling in the same direction. So we should find the time for A to completely pass B. So first we have to convert all the units. So we'll convert them to meter per second. 60 kilometer per hour is equal to 60.67 meter per second. And for B it is 40 kilometer per hour, which becomes 11.11 meter per second. Okay, now we have both meter per second. Calculate relative speed. So relative speed is 16.67 minus 11, that is 5.56 meter per second. So this is the time taken for the um, train A to cross. So total distance to cover is 200 plus 50, 150 minus 3 is equal to 350 meters. So time is equal to speed, distance by speed. So that gives us 350 divided by 5.56 is equal to 63 seconds. So work it out and try to see if you can get the same answer. So here we have another question. Just go through the question and try to solve it by your own. Similarly, we have the relative speed problems where two objects are in opposite directions. Train A is equal to train A 180 meter moves at 72 kilometer. Train B, that is 220 meter, moves at 54 kilometer per hour in uh, opposite directions. So we have to find the time taken for them to completely pass each other. So converting the speeds to meter per second, 72 kilometer per hour of train A becomes, sorry, 72 kilometer per hour of train A becomes 20 meter per second, and 54 kilometer per hour of train B becomes 15 meter per second. So calculate relevant speed. They are in opposite directions, so we have to sum them. So it is 35 meter per second. Total distance to cover is 180 plus 220 gives us 400 meters. So time is equal to distance plus speed. That gives us 400 divided by 35. That gives us 11.4 seconds. So it takes 11.4 seconds to completely pass each other.